Thank you so much for a lovely introduction. So first of all, we'd like to thank you for the opportunity to come back and speak again. And I would also like to say thank you to those of you that don't have your native tongue in English and you sat here all day listening. It's not easy to do, and I just want to say thank you very much for that. So let's get on with our presentation, so about how to automate engineering. And it goes beyond just engineering. It's how to automate your processes as a whole. So first of all, let me tell you a little bit about Rockwell Automation. So we're an industrial automation company. So basically, we have everything from terminal blocks all the way to doing custom systems and solutions for our customers. We're in a number of industry, all the big normal industries, oil and gas, food and beverage, consumer products, that sort of thing. But and what we do is we help our customers to be able to be much more productive by putting in the automation in their processes. And as you look at the journey that we're going through for ourselves, more and more we're realizing that we can help our customers too. Make sure I do this. Okay, so we're going to walk you through a little bit. That's why we're going to kind of tag team it here a little based on different people's experiences and what they had ownership on. So I'm going to talk a little bit about the journey. What was our sense of urgency? Why was it that we had to reach out to EPLAN to kind of look at our processes and rethink what we were doing? And then Agnieszka and Adrian are going to talk a little bit about and demonstrate how we've automated our parts generation. And we are a very highly configured business, so you want to take as much time out of the process as you possibly can. And then last but not least, Christoph is going to talk about how do you take it from a small part to a big system and really leverage the automation. So here's a little bit of a story from our perspective. So as you look at it, we had a sense of urgency and a need to change. So with Rockwell Automation, we have a very large portfolio of products, like I said, from terminal blocks, motor control centers, all sorts of different types of supports and services and actual products. In our catalog today, we have over 400,000 components and products, and a lot of those can be turned into bigger and bigger systems. So that adds a whole level of complexity. We're proud of what we have to offer for our customers as they go to automate their lines, but at the same time, it does bring in some challenges. When I stepped into my role in 2012, I had an opportunity I was a business leader for one of our packaged businesses, so putting components into panels. And I took a look around at what they were doing, how they were doing things, and it astounded me that we had 3 engineering tools that were over 30 years old and written in Cobalt. So how many of you remember Cobalt, right? Yeah, all of us, we're a little bit more older. Cobalt just celebrated their 60th anniversary this year. So again, think about if you had a mobile phone that was over 30 years old or whatever. You're just not going to be efficient. So we had to look at ways to change what we were doing and just start with a clean slate. Then we also had the changes in the marketplace where our customers were trying to make their processes shorter and shorter. And one of the things that they were doing is not only did they want to buy the individual components from us and build their machines, they wanted us to build the products, build them some sub-assemblies, and be able to get it to them so that they can put it into their systems or their machines. Well, with that came the expectation that they wanted these parts in a lot shorter time frame than we were used to. So we had this opportunity to just really rethink and start with a green space. And we really started digging into it about 3 years ago, really. When you start looking how far we've come in the last 3 years, it's pretty exciting. Preparing for this conference gave us a chance to kind of look back and reflect on what we have done. So one of the things that was our major activity of what we were trying to do was to sell more Rockwell Automation parts. Or parts, services, whatever that was. So as you look at, and somebody was talking about it earlier today, I think it might have been Haluk, it's really an ecosystem, right? So you look at our distributors. So we have a strong distributor base, and they're working really hard to sell our products and services to our customers. Then we have what's called Encompass Partners. These are people that we bring into the fold that sell products that we don't do anything with, but help our customers to automate their lines. We also work with systems integrators, original equipment manufacturers, and obviously the end users. So as we're starting to look at this, EPLAN really enabled us to optimize our processes as a whole. And we one of the things that we did is we kind of took way too much on all at one time. But looking back, I don't think we would have been as far as we are if we hadn't jumped into that pool and just started figuring out how to swim. But EPLAN is a good enabler for us, but one of the things I told you before is we wanted to make sure that whatever we were doing for ourselves, whatever automation we put in, we have to be able to do that for our customers. And one of the other speakers said, you know, if you don't have your products and your data attributes in the database, in the parts library, then you're not going to be a supplier. So we recognize that, and we want to make it much easier for our own customers. And then it also gave us the opportunity to start expanding what our distributors could offer. So many of our distributors were making the transition from pick, pack, and ship, distribution type things where they have products and they're shipping it, to really wanting to add value services. So one of the things that we were looking at was how can we leverage the information that we created so that they can use it. So instead of having distributors creating data, they were using the data and leveraging a lot of the Rockwell Automation tools that are out there today. So we really saw this as a full life cycle from, as we go forward and what we wanted to attack. So let me tell you a little bit about the good, the bad, the ugly of what we walked into. So like I said, we had a big burning platform, a big sense of urgency to do some things. And one of the things that we did was before we started putting in a whole slew of automation, we cleaned up the mess that we had that had grown over how many ever years, 30-something years by different engineers. So we modularized our products. We looked, everything was on the table. We looked at a couple of things that we did was really reduce the number of enclosures we have. Because you struggle with lead time on enclosures. So how can we reduce that by getting some standardization? We changed the power wires that we used. Again, limiting the number of power wires and reducing the operations time from an assembly perspective. We also looked at our bill of materials. So we're a strong SAP user. We use KMATs, configuration variants. And we felt that if we could modularize these KMATs like we've modularized our products, you just start taking the friction out of the processes. So as you can see, we really had some success for standardizing, modularizing, and then optimizing our processes. So while they were trying to figure out and understand the technical attributes of EPLAN and how to understand it, we had another team that was just cleaning up the mess at the same time. And you can see from the results, when we first started out, we had over 3,000 bill of materials a month. 3,000. Takes on average about 50 minutes to resolve from the time it hits the floor to the time it goes to the front office to the time it goes to the engineer to the time it comes back to the floor. 3,000, 50 minutes apiece, that's 2,500 hours a month of downtime. Now you want to know why your products are costing so much. So it really, with EPLAN, we were able to, and the modularity, take our BOM errors down to less than 100. So it's been a great success for us. We've been able to grow our business, which was one of the major goals. And then also we were able to reduce the time to assemble the products. So as you look at our overall journey, we had the legacy products, the legacy tools. We had to get rid of those. We wanted to migrate to database and rule-based systems because it's just going to give you so much more capabilities, putting it in, being data ready. How do you look at your products differently than from an engineering perspective to be a data attribute? What data attributes are important? So we really started leveraging the tools from the EPLAN. And then we did what I call a proof of concept. And this we partnered with EPLAN to kind of understand it, build it. We took a small assembly and really wanted to test drive the tools and try to prove to our senior management that it was something that was doable. So as you can see, we had some pretty significant improvements in reducing our engineering time. That helped us to grow. We didn't have to let people go. It just enabled us to go after more businesses. And then what you'll really see that's kind of exciting is what they've done with the systems architecture from our systems and solutions that Christoph's going to talk about in a little bit too. All this automation is really preparing us for the future. We really have to do the work to put in the cloud, the virtual reality, AI, all the stuff that you're starting to see becoming more stable. This will better prepare us for that for the future. So with that, I will pass it to my colleagues.
Thank you. It's working? Okay. Hello, my name is Adrian Kuszper, and together with Agnieszka Saboa, we're going to talk about automated parts generation. We're a part of Rockwell digital engineering team located in Katowice, Poland. And one of our main responsibilities is to create the EPLAN parts for a Rockwell parts library. And as Sheila said, we have over 400,000 of parts available in our portfolio, and it's not possible to create all of them quickly at once. So we, in the past, created a schedule using 2080 plan, which means by creating about 20% of catalog numbers, we can cover more than 80% of our sales revenue. But then we asked a question: what about the rest of 80% of catalog numbers? Or what about the highly configured products that we have in our portfolio? They have a pretty high sales revenue as well, so we need to somehow create them too. And it's a huge effort to do that manually, so we decided to use EEC for that. And what are the advantages of this approach? It reduced the parts creation time significantly. The automated creation is much more faster than the manual creation, I think that's clear. Its created model is universal for all the products from a specific product group. It's easy to use. The end user receives the package of data which they need for the projects, and it increases the sales volume. The more parts we are able to generate, then there is a higher probability for the customer to use it in the project and in fact to buy a product. And here we prepare an example. Together with Agnieszka, we created an EEC model which is able to generate the parts for an operator device product family, and which is actually our proof of concept that's possible to automate part generation, and is actually working very well. This product family is highly configured, so there are billions of possible catalog number combinations. And once the model was developed, then we measured the time which takes us to create the part manually versus to create a part using EEC. And the 15 minutes is the result that we get to create the part from scratch manually, and 30 seconds is the time that EEC needs to create a package of data. This model is universal for all operator devices, like, for example, push buttons, selector switches, pilot lights, e-stops, etc. And in the end user receives all the information as a one package of data, which contains 3D macro, connection point pattern, drilling pattern, and all the technical data that the engineer needs for the project. Now we can dive into details.
Is working? Okay. So I will tell you something like briefly how our model looks like and what we needed to do to make it work. Well, first of all, one need to go through the whole bunch of technical documentation, so like product specification or installation instructions. The information we want to get from here is what elements are needed for our final part, what are the rules for those elements to combine with each other, and what are the characteristics and attributes of our final part. When we have this data, we can move to EPLAN, and then we take all the rules and all the data, and we convert it into the EEC model. We create the necessary libraries with components, we build a structure, and we apply dependencies between those components. Our model, the only input that requires is the bulletin number. Then through the EEC generation, we get the package of information that contains everything that we need. And all that you need to do now to be able to use the part is just import it to your EPLAN database. And now we have a short video. I hope it's running. Yeah. So this is our development environment. We here put our catalog number and we run the generation. This is our output folder. In the moment you will see when the EDZ file appears. So here is our EDZ file with all our data. Now when the installation is complete, we move to EPLAN. Here I have empty database and I go for import of the EDZ file. And here we have our part. We have all the necessary information that we need. We also provide a multilingual input. We have all the descriptions and everything. We have our mounting data with 3D macro and the picture, our technical data with connection point pattern, the manufacturing data with drilling pattern, a function template. It is also configured in EEC, and we can assign properties here, not so many because it's just push button. And all you need to do now is just insert the device. And since we have only one, so we go with this one, we can place it on the, let's say, on the door. And it contains all the information like our connection points and the directions for the connection points. And we also have the information about the drilling pattern.
Hello? Oh, okay, it's working. Okay, what are our next steps with this solution? Well, first of all, we want to make this solution available for the end user, for the customer. We're collaborating with EPLAN to implement our model and our proposal configuration on EPLAN data portal, and we want to also implement our model on our proposal work software itself too. Okay, previously I talked about operator devices, but there are much more products that we can automate using EEC. And for example, we can do the same for stack lights, for drives, for contactors, for disconnect switch kits, relays, and many, many more. Why this is important from a system perspective? So every time we need to start to get all the individual parts. Then we can use all the individual parts to create an assembly. And then we can use assemblies which we can build into the systems. And now we can move to the systems itself.
Okay, hello. My name is Krzysztof Soligowski. I'm with the system solution business in Rockwell. And I'll tell you a bit about systems and how we use the EEC for those systems. So I'll start off with the connected enterprise. It's an aspect of Industry 4.0. It's our vision of Industry 4.0 in Rockwell Automation, and it's about connecting the plant floor devices, systems, and those systems into the enterprise level. It's done through the convergence of IT and OT using cloud for edge computing. Now, the data in that enterprise model, connected enterprise model, is process data, which is during the machine run or the process run. There's also software data and hardware system data. So what is hardware system data, and what is a system? So a system usually starts off with a machine or a process. That machine has some actuators, it has sensors, it has inputs and outputs. It has a logic element to it, which makes it work, and it also has some infrastructure, which connects all of those elements together. That infrastructure, from our perspective, is usually some sort of enclosure. It has some power, some control circuits. It connects the on-machine installation together. It also connects the bus systems together. So all of those 6 elements, they form our hardware system data. Now, if you take that model back and line it up against the automation life cycle, the software data and the hardware data, they need to be developed at a much earlier stage in the automation life cycle. So we need to develop that data in the design phase. So now let's go into that design phase. Designing a system is a complex topic. It requires a breadth of knowledge. It requires multidisciplined engineers who can cooperate in different disciplines across different engineering disciplines, across different departments. So as that engineer develops his his hardware system data, his infrastructure. He needs to, as he's moving from that standard sort of crafting engineering into a digital engineering world, he needs to add more data and add more complexity to his design. So that enclosure data needs to be more enhanced. For example, assembly solutions need to be engineered out at the beginning of the design phase, not during manufacturing of the panel. So, for example, trunking, it's no longer a rectangle on the layout. The routing definition it's no longer an instruction for the fitter wireman on how to route, where to route the wires. That detail needs to be entered by the engineer at an early stage. Cable clamps, they're no longer a packet of 100 going to the shop floor. What does this mean? It means the BOM is more detailed, the drawings are more detailed. And we all know the BOM is the reason why a lot of engineers get up to work in the morning to put that BOM together. It's a lot of work for the engineer. And there's a lot of other topics around system engineering that needs to be taken into account. So it's a lot of work. So what do we do about it? Well, we need to start automating. And this is where we use the EC. And I'll show you what we used, how we used it on what we call the EPLAN V2 project, where we designed and created an EPLAN design tool for our internal use at the moment. So we start off with the hardware system data that we need to create. We defined a set of inputs. Those set of inputs are a sensor or actuator. It's an actuator at the beginning with a motor. That motor has a machine function. It has a control method. And it has some engineering data, including design conditions, kilowatt ratings, amps, etc. So that set of inputs that set of data is our input data. We used our internal ProposalWorks tool, which is also available to outside users. ProposalWorks as a front-end configurator to feed in that data into our generator. So the generator was EEC, and the outputs that we generated were a set of documentation. We generated schematics in multi and single line, pro panel layouts. We also added a BOM that was generated, and a PDF and a 3D PDF of the panel layout as well. That data formed the hardware system data, or that output formed the hardware system data, and we also used our internal suite of software development tools to auto-generate code. And that PLC code formed part of the software data. How did we align those two worlds together, the hardware and the software? Well, we used the functional approach. So when we look at the machine, the machine has a function. The individual elements of that machine have functions and sub-functions. They have control methods. That's the approach we used in the configurator. And our application code manager, which is our generation tool, also works on the functional approach with a control method for each type of actuator. So let's have a look at what happened in the background behind the curtain. Our approach was a design elements approach. We started off with parts. We have a set of parts that we typically use for our projects. We have generic functions. We have a set of rules that link those, tell us how to link those parts with the generic functions. And we generate an actuator circuit. So that's a configured element. That was the first step. But then we took it a step further. And the challenge we had around automating a system is we started off with that actuator function, but then we had to include and take into account the connections, the relationships between the infrastructure of the whole system. So we had to calculate panel space. We had to calculate the power that the actuators and some of the control circuits take. Also, the control circuits had to be calculated and developed to cover up the actuator needs, and also the enclosure needs like cabinet services. We also calculated and generated a set of inputs and outputs to facilitate the needs of those actuators, those actuator functions. So here we combined a couple of things. First, we generated circuits, then we calculated circuits, and calculated space as well. So what were the outputs of that tool in more detail? We have a structured project. We have a single line diagram for the entire power section up to the control voltage. We have the multi-line diagrams. In terms of the actuators we generated, we didn't generate all types of actuators. We started off with a motor driven by a VFD or direct online starter, and we generated the infrastructure. The power circuits and controls were calculated. We generated a grounding scheme for the entire panels that were calculated and generated. Cabinet services were also covered through that generation. So all the fans, air conditioning units, the cabinet lights, those sort of basic elements, that was all generated. And we allocated I/O for each of the functional groups and their needs. From a layout perspective, we generated the 3D layout of the entire panel suite. It generated bus bars, also calculated based on SCCR ratings, on design conditions, also different solutions for different types of, different loads, different types of currents. We also added a spare panels feature as well. But that's not all. So in the future, we're looking into other types of actuators. We'll be looking into automating bus systems, on-machine installation, the safety aspect, advanced routing, and many others. So now, if we circle back to that connected enterprise and Industry 4.0 model, we can write a scenario. So we, for example, at the enterprise level, we could have a predictive maintenance task identified at an early stage. We could, at the enterprise level, identify all the locations of our drives across our plants, across the entire globe. And when it comes to actually replacing part of that drive, for example, a heat sink fan in the drive after 5 years, the maintenance team could use that hardware system data we developed at the beginning in the design phase to get a lockout-tagout procedure, to get a technical data sheet, pick up a bill of materials for their work, look at the schematics that we generated, and look at the layouts. And if it turns out that a cable maybe is damaged in the panel, then they could use that routing data that the engineer generated through that logic piece of trunking. The maintenance team could look at where that routing is placed and where how they can replace it quickly. So I'll bring it back to Sheila.
Okay. So a couple of things, some recommendations. I mean, we did this in 3 years. It's pretty amazing when you look at, we were trying to solve a bill of material error problem, and now we're solving so much more complex engineering challenges. So it's really exciting to kind of take that look back. My recommendation is do it in steps. Doing the proof of concept first to get management's buy-in and see the vision of where you're trying to go really made a big difference for us. And then we did a pilot before we started rolling it out any further. So those are kind of take it in steps, get management's buy-in, I talked about that. So the other thing is standardize your products and your processes. So don't try to automate a really bad system. So go and clean up the system first and then put in your automated processes. And like I said, you can do it in parallel. You just have to make sure that where you're trying to go. And do not underestimate the change transformation effort. So Rockwell Automation is an over 100-year-old company. And I'll tell you, when it comes to changing how we do engineering, it's not easy to convince people to see what the vision and the possibilities can be tomorrow. It took a lot of work of advocating with our leaders across the organization, getting them to believe in what we were trying to do in order for them to invest in it. So we were really happy to be able to, through the proof of concept and the pilot, to be able to invest in a team, and now we've turned around and shown the return on investments. So with that, we just have a little video for you that Christoph's team shared with our organization. You'll see an acronym here, CP&S. It's called Control Products and Solutions. That's part of the group within Rockwell Automation that we work with. So cue the music there, sir. Do I have to start it, or is it going to go? Thank you very much.